Welcome to Lab. We will be learning about acid-base titrations and buffers today. Please view your text about these concepts. Let's go over some safety. As always, goggles and apron must be on at all times. People with long hair need to put their hair up, and any dangling clothing or accessories, such as jewelry, need to be taken care of. We will be working with acids and bases. Contrary to popular belief, bases are often more harmful to your skin than acids. Regardless, both can be dangerous and need to be handled with care. If you happen to get any base or acid on your skin, rinse the affected area for 2 to 5 minutes.
For Part A, the base we will be using is 0.3 molar sodium hydroxide. Using your knowledge of concentration, you should realize that this is quite dilute. The acid we're using is acetic acid solution, which is commonly called vinegar.
The problem is you don't know the concentration. Your task is to determine the concentration of the acetic acid. The method you will be using is called titration, specifically an acid-base titration. Titration is a method where you have a known volume of a compound with an unknown concentration, and you add a known volume of a compound with a known concentration to the first compound to produce a reaction in order to quantitatively determine the concentration of the unknown compound. In this experiment, you will be performing a neutralization reaction. The chemical equation is:
acetic acid reacts with sodium hydroxide to produce sodium acetate, a salt, and water. Since this is a neutralization reaction, the pH should be about 7 when the number of moles of acetic acid and sodium hydroxide are the same. You'll be using a burette as shown in the last lab. Transfer enough sodium hydroxide into the burette to get past the 5 milliliter mark and adjust the meniscus to 5.00 milliliters. Make sure there are no bubbles in the tip. Another method of delivering an exact amount of volume to glassware is through a volumetric pipette. Each piece of volumetric glassware is marked with its total volume, the notation TD or TC, and a temperature, usually 20 degrees Celsius. The marked temperature indicates the temperature at which the apparatus was calibrated. The notations TD and TC stand for the phrases to deliver and to contain, respectively. The TD notation, used on burettes and pipettes, means that the apparatus is calibrated to accurately deliver or transfer the stated volume to another container. The TC notation, used on volumetric flasks and most graduated cylinders, means that the markings give an accurate measure of the volume contained, but that pouring the liquid into another container will not necessarily deliver the indicated volume. A volumetric pipette can be tricky at first, so it's good to practice using a beaker of tap water first. Place the tip of the pipette in the water. You will be using a bulb to suck up the water. Squeeze the bulb, place the bulb firmly on the top of the pipette, and slowly release the bulb. Take up enough water so that the meniscus is past the fill line. Quickly take the bulb off of the pipette and put your finger over the top of the pipette hole. Take a look at this again. This is usually the most frustrating part. Take the pipette out of the water and carefully allow some of the water to leave the pipette until the meniscus reaches the 5.00 milliliter fill line. Take your finger off of the hole to dispense the liquid. After allowing all of the liquid to gravitationally dispense, you need to touch the tip of the pipette against the side. This makes the dispensing more accurate. Make sure you do not blow out the last drop. Remember, the TD notation means that whatever is dispensed is the correct amount. After practicing this a few times, you should be ready to do the acid. You will be dispensing the acid into a new piece of glassware called an Erlenmeyer flask, or simply a flask. In order to know when the pH reaches a certain level, a pH indicator is added to the acid in the flask. We will be using phenolphthalein.
The pH of the acetic acid is about 2.4. Phenolphthalein turns bright pink at a pH of about 8. We want to stop adding sodium hydroxide at a pH of about 7. This means we want the phenolphthalein to be the lightest pink color possible.
The flask on the left has not changed color yet. The flask in the middle is the light pink you will be trying to get, which is called the endpoint. The flask on the right is 1 drop beyond the endpoint. This means you have to titrate slowly and carefully. The technique for adding the sodium hydroxide is you need to open up the burette to a steady drip with one hand and, using the other hand, swirl the liquid in the flask. Swirl the flask on the counter to prevent dropping it. As you get closer to a pH of 7, the liquid in the flask will remain pink longer but will disappear with stirring.
For Part B, you will be studying buffers. Please review your text regarding buffers. You will be checking the pH of the solution you create.
Take a drop of your solution using a glass stirring rod and touch it to a piece of pH paper. pH paper changes color depending on the pH. Using the color indication paper that comes with the pH paper, try to compare the center of the color change with the paper. It may be difficult to estimate, so use your best judgment. Don't estimate between pH numbers such as 12.5, simply record your best estimate.
If you need help with any of the write-up, please speak with your instructor.